The League of Women Voters presents Utah's new energy sources. Ground source heat pumps for greener heating and cooling.
My name's Justin Owen. I am the energy manager for Weber State University. In 2007, Weber State made a commitment to become carbon neutral by 2050. And that kind of started this snowball of energy and sustainability initiatives at the campus. A lot of people aren't familiar with heat pumps, but they have been used for a long time. The refrigeration cycle is a very proven technology. The main reason we're moving to heat pumps as a campus is because we want to get rid of direct combustion of fossil fuels. And the other is under this view.
Weber State already has 3 ground source heat and cooling units.
And welcome to the NORDA Center for Engineering, Applied Science and Technology. This houses a number of our technical programs: computer science, mechanical engineering, electrical engineering, and so forth. So it's a completely electrified building, and it has its own ground source fields. What we're really doing is, you can kind of think of it as we're using the ground or the earth as a heat battery. And we're drawing on it when we need to, we're charging it during other times, and then we're moving all that energy around through these refrigerant systems.
How does it work? 1. Water circulates 24/7 in an underground water loop. 2. The water heats up to 55 degrees underground. 3. Water vapor mixes with refrigerant and gets hotter. 4. Hot air blows into the room until the desired room temperature is reached. Let's take a look.
It's wintertime right now, and our spaces need heat. So I have water flowing through our building, and these heat pumps right here take energy out of that water and move them into the refrigerant lines, which then go to the spaces.
Refrigerant? I thought that was really bad for the environment.
There's a number of concerns with refrigerant: ozone depletion, global warming, toxicity. The refrigerant we use is non-toxic, it's non-flammable, it doesn't deplete the ozone, but it is a potent greenhouse gas, so we have a strict refrigerant management program. We do lots of quality control on our installs, lots of commissioning there.
Is it better for the environment than natural gas heating? Yes, it's far cleaner than drilling, transporting, and burning natural gas. Is it more efficient than natural gas? Yes.
Right now it's 42 degrees Fahrenheit. We're in the middle of our engineering building. There's a lot of internal heat load, and this building is very well insulated, right? So even though it's pretty cold outside, the central area of this building will not need any heat because there's computers, there's people, and it's well insulated. So only the outside needs heat. So these heat pumps can actually do that. And sometimes I might have a computer lab with 40 people in it, right? That's in the inside of a building, and it might actually even need cooling this time of year. What the heat pumps will do, because of that refrigerant cycle I was talking about, will take heat from that computer lab and move it to the exterior classrooms of the building, right? So I'm moving heat around within a building. I don't even necessarily have to get energy from the deep earth. I might already have it inside, which is pretty cool.
And there are more benefits.
One of the advantages of moving to a heat pump in an electrified building is it lets you downsize your fan systems dramatically. And I've actually seen, so our social science building, for example, we decreased our energy use by about 70%. Total building energy use, including all of our plants, lighting, all of that.
Did you get that? We decreased energy use by about 70%. How does it work in the summer?
We're moving energy from the deep earth into our buildings during the winter, and from our buildings into the deep earth during the summer. It's 110 degrees outside. The building wants to heat up. We have lots of people, we have lots of computers, equipment, or whatever. So what the heat pumps will do is remove that heat. It goes through the refrigerant lines, goes into the water, warms the water up. Once the water gets warm enough, our deep earth temperature is about 55. So if my water's 70, I can send it underground and cool the water that way.
Does it work in really cold climates?
There's a few misconceptions about heat pumps. One is that they don't operate in cold temperatures. Most manufacturers now offer heat pumps that perform well at very cold temperatures like we see here along the Wasatch Front. And really what they do is they have an extra pass of refrigerant, so the refrigerant gets a little warmer on the compressor. Those are available both in commercial and residential applications, so you can install them in your business or your home.
Isn't it costly?
Another misconception is that it's more expensive than natural gas heating. That's actually not true. Performance has increased to the point where heating with an electric heat pump is actually cheaper than natural gas. So your total utility bills, if you're choosing efficient equipment, will go down and your total cost of operation will go down. The other thing I'd mention is there's a number of new tax incentives available in the Inflation Reduction Act, both for businesses and for residential customers to install their own heat pumps.
How deep do you have to drill for the wells?
Each of our fields has, between 110 and about 200 wells per field. And in terms of depth, basically what you do is you drill down until you hit bedrock. And then it's cheaper to just drill another hole. If we're on top of the hill here, so up by the football stadium, it's about 270 feet deep. If we're down at the bottom of the hill, it's about 400 feet deep.
Can I do this for my home without drilling holes in the ground? Yes, with an air source heat pump.
There's two kinds of heat pumps. One is what's called a ground source heat pump, and that's where you're drilling, you're sending water underground, and you're using the earth as your battery to move your heat back and forth. That's not what I would recommend for your typical residential customer, or a small commercial customer. So the other kind of heat pump is what's called an air source unit. So instead of having a big underground well, that heat pump actually gets its heat from the ambient air. And so you don't have to drill anything at your home. You can have an installer come in. They actually have units that go in the existing footprint of your air conditioning compressor, your condenser, and your furnace. And so you get a new outside unit, you run some new refrigerant lines, put a retrofit kit in your furnace, and then you've electrified your home.
What will the next advances be?
If somebody could develop a green refrigerant that has good performance, we'd move to it, right? And that person would make a lot of money.
For me personally, I'm very motivated by climate change, and I've seen, changes within my lifetime, and particularly along the Wasatch Front, as we're talking about the fate of the Great Salt Lake, for example. The fate of the Great Salt Lake and climate change are interconnected, right? And I think it's something we should all be concerned about. Now we're seeing other things happen across the world, increased flooding, more extreme weather events as we see climate change have a greater and greater impact. So for me personally, I get a lot of satisfaction knowing that I'm trying to be at least part of the solution in transitioning. And I feel like the planet will exist without us just fine. It's more humanity and quality of life that I'm concerned about.